Okay, so the properties of a rhombus. Okay, so what a rhombus looks like. Okay, so to understand what a rhombus is, you know the definition, and it is a parallelogram with 4 congruent sides. So much like when we did a rectangle, a rhombus has all the properties of a parallelogram plus some other properties that make a rhombus a rhombus. So I know that all 4 sides are going to be congruent. Okay, so if we were talking about the properties of a parallelogram, so let's see, properties of a rhombus. And if you have more than one rhombus, we do not say rhombuses, we say rhombi. Just more of an FYI. So if I say rhombi, you don't think that I'm going crazy. So the properties of a rhombus, we have those 5 properties of a parallelogram. And so because it's a parallelogram with 4 congruent sides, that means it has those same 5 properties. I'm not going to write those down. You've had those in your notes twice now. But what makes a rhombus is that not only do you have 4 congruent sides, which is part of the definition, but you also have diagonals, bisect each angle. So that means that if you have, or if you know that this is a rhombus and you have a diagonal, that does mean that these angles are congruent. If I have a diagonal zipping through here, that means that those two are congruent. And because it's still a parallelogram, and we have alternate interior angles, then that means that these are going to be congruent by alternate interior angles. And these will be congruent by alternate interior angles. The last thing that's important about a rhombus is the fact that diagonals are perpendicular to each other. So what that means is that where they intersect, that creates a right angle. So if you have one right angle, that means you have 4 right angles. So what you are creating is you end up with 4 congruent right triangles. Okay? And one thing you might want to be thinking about if we are talking about congruent right triangles is in a right triangle, if you're missing some pieces, you might be thinking about the Pythagorean Theorem of a squared plus b squared equals c squared. We might get to one of those examples yet today. Okay, so if we have a quadrilateral, we'll name this MNOP. And we have the diagonal zipping through here. I'm going to change this. We are going to know that it is a rhombus. And the intersection is going to be T. We have M, N, O, P with intersection T. If I know that NO is, let's make this 13. If I know that NO is 13, because I already know it's a rhombus, all the sides are congruent, so that makes every side also 13. If I know that MO equals 10, so if MO equals 10, this whole thing equals 10, because it's still a parallelogram, I know that diagonals still bisect each other, so that means that this piece here would be 5, and TO would also be 5. What happens if I ask how long MN is, or excuse me, PN is? Do I have enough information to find out how long PN is? The answer is yes, because also in a in a rhombus, we have a right angle. I'm going to kind of isolate this right triangle so you can see what I'm talking about. There's my right angle. This is 13 and this is 5. There's my T and there's my N. But I'm looking for PN. But I know that diagonals bisect each other, so if I know TN, I can just take that times 2 to get my whole length segment of PN. If we look at this, we are missing this length. I can use the Pythagorean theorem because it is a right triangle. So the hypotenuse is opposite the right angle. So I know a leg squared plus the other leg squared, which is missing. I'm going to label that as x, equals the hypotenuse squared. 25 plus x squared equals 169. Subtract 25 on both sides, I get x squared equal to 144. So I have x equal to 12. So what we just found is that TN is 12. So if TN is 12, then that means PT is also 12, which means PN is 24. So that's going to be one of the ways that you're going to be using the properties of a rhombus, using the fact that the diagonals are perpendicular to each other. And don't forget about what we did up here with alternate interior angles and the fact that all the sides are congruent.